Hello, by the end of today's lesson, you should be able to write really big and really small numbers in scientific notation. So like I said, the purpose of scientific notation is because when you're doing calculations with really big and really small numbers, having all of those decimal places or all of those placeholders can be a huge challenge. In fact, the screen of a calculator is only so big. So if you have a number that takes up, 12 places and your calculator only goes to 14 and you're multiplying numbers together, you just don't have enough space. So scientists came up with scientific notation. Sometimes it's helpful to write why we do something. We're going to write the purpose of scientific notation here.
Scientists use scientific notation to do calculations with really big things.
So I like to think of space, like traveling through space. If we're going to explore Mars and we're talking about the distance from Earth to Mars and the amount of fuel and the amount of oxygen that we'll need, we're going to be dealing with really large quantities. So we're going to need to use scientific notation. Or something really small, like DNA or viruses or, just even pieces of DNA. You're going to be talking with really small measurements and things. The key to writing in scientific notation is you can only have one digit to the left of the decimal. So I'm going to star that and say only one non-zero digit to the left of the decimal. So let's take a really big number. So I'm going to take a big number like maybe 2. Okay. So, and yeah, it probably has those little commas. Make it easier to read. Okay. So if I were to type this into the calculator, I don't even know if it would fit, because depending on the calculator, it might not have enough space for all of these zeros. So that's why we come up with scientific notation. So it says only one non-zero digit to the left of the decimal. So right now, the decimal is right here. And I only can have one non-zero digit to the left. So I'm going to take this decimal and I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. Because I'm moving it 10 places, that means that I'm going to take 3, that's where my decimal is, 0.52, and to make this equal this same number, I'm going to need to multiply that by 10 to the 10th power. Now, it's not by chance that I moved this decimal 10 places, and that's the exponent. That's how you calculate the exponent, is you literally just count the numbers, okay? So you count the number of spaces the decimal moves. This is the exponent on base 10. Okay? So what about really, really small numbers? Now, a really, really tiny number would be something like 0. do 7, 8, 3, 4. Okay. Now, once again, count or only one non-zero digit to the left of the decimal. So that's 0. That's not going to work. So 1, 2, 3, 4, 5, 6, 7. So I want the decimal to be there. So I'm going to take 7.834. That's something I can put in the calculator. Times 10. Now I had to move the decimal 7 places, but this is a really small number. And I moved the decimal to the right. So that's going to be negative 7. Okay. Now, here's my little thing. You can memorize a negative is to the right and a positive is to the left, except when you're moving out of scientific notation and you're putting it back into regular and standard notation. It's the opposite, and then you're going to get it all confused. So instead, you just need to use your logic. Are you dealing with a really small number like this? Is it really super tiny? If it's a really super tiny number, like this one is, right? It's a very teeny tiny fraction of 1. Then it has a negative exponent. If you are dealing with a really big number, like distances in space, or the number of atoms in this pencil, then you are going to be dealing with a positive exponent, okay? If you can just think it through, and either are you dealing with a really big number or a really small number, then you will never get it mixed up. If you try to memorize the left and the right thing, you can get those confused. And then you say that the distance to Mars is a fraction of a centimeter away. And, well, that's just ridiculous. So, this is my key here, okay? So, really big numbers. So, big, and I abbreviate numbers like this. I know that that's the hashtag sign now, but that's what it is. Have a positive exponent. Small numbers have a negative exponent. 8 times 10 to the 6th. Okay, now that's 8 times 10 to the 6th. That's a positive exponent, so we know this is going to be a really big number. So right now, the decimal's right there. So we need to move it from here over 6 places. So 1, 2, 3, 4, 5, 6. I love using the swoopy method because then you just add in your zeros every place where there's a swoop. And now you can put in your commas if you want. So, yeah, I mean, that's a big number, right? So 8 million. 0. Or you could have 8.0 times 10 to the negative 6. Now, it's a negative, so it's a very small number. So a very small number, we're going to know has a lot of zeros in front. So I'm going to put the 8 way back here. The decimal's still over here, and I'm going to swoop it this way. 1, 2, 3, 4, 5, 6. Because I know this needs to be a small number. Then I'm going to put the decimal here. I'm going to put the zeros in the space. You should always put a 0 in the front. Okay? And we went from scientific notation to standard. We're up here. We had standard, we went to scientific notation. Notice how each time we counted where the decimal was moving. I suggest you actually do the swoops, okay, to help you count. Otherwise, especially if there's a lot of zeros, you might lose track as to where your zeros are. Go ahead and write it on your paper. If you're using pencil, you can erase it later if you don't like the look of it. Okay, so over here, pull out important information down at the bottom. I suggest you come up with some of your own, both in scientific notation to standard and standard to scientific notation, both really big and really small versions. Thank you.